Welcome, I'm GamerPatty, and today I'm going to review this FeelTech FY6800 function generator. I bugged it with my own money, so there is no sponsoring. Let's turn it on. I'm running the version 1.6 and I got the 30 MHz model. The FY6800 is a 2-channel function generator with a counter and some I/O on the back, like sync ports if you want to connect multiple of these, up to 8, TTL and serial, also USB for the control suite on the PC, which allows for custom waveforms. It has a built-in 64 waveform storage, and there's models up to 60 MHz. So let's take a look at the menus. At the main menu, which pops up if you turn it on the first time, or after the welcome screen, you can see both channels. You select one channel by pressing the channel button you want to select. Currently, channel 1 is selected. I can currently change the frequency in the megahertz, kilohertz, hertz, millihertz, and microhertz, which I don't think it's that accurate. And to change the cursor, we can click these buttons, which allows me to change the amplitude, the offset, the duty cycle, which obviously doesn't work on a sine wave. That's why I can't do anything. And the phase, which is the phase between channel 1 and channel 2. On the right we have 6 buttons. First is the wave. If we click wave, we can change the waveform. It's standard, skips one forward, so if you go back one, we got a sine wave again. There is square wave, CMOS, which is at the base it's 0 volts, but it goes up to the amplitude. An adjustable pulse, a DC voltage, a triangle, a ramp, an inverse ramp, a stepped triangle, a stepped ramp, a stepped inverse ramp, positive exponent, negative exponent, positive fall exponent, negative fall exponent, positive logarithmic, negative logarithmic, and so on. And we got a positive full wave, negative full wave, positive half wave, and so on. Lorentz function, the multitone, random noise, which isn't all that random, it's just a pattern that repeats and repeats. And ECG, a trapezoid, sync pulse, an impulse, which is a very short impulse, an AWGN, not sure what that is, an AM modulated signal, an FM modulated signal, chirp, and the 64 arbitrary waveforms you can save on the software that's been supplied with. To change it back on sine, we don't have to scroll all the way back. We can change between the arbitrary waveform section and the standard waveform section, which we can go back to save some steps by pressing the OK button 2 times. To change over to channel 2, we just select channel 2, and now channel 2 is selected and we can do the exact same things. Let's select a square wave on this channel. A square wave with 1 MHz, an amplitude of 5, which is the volts peak to peak, so 2.5 volts positive minus 2.5 volts negative. An offset, DC offset, the duty cycle, but we also can change, if we press duty once more, the rise time and the fall time, which is currently set to 8 nanoseconds. But the minimum is 4, not sure why it's not standard. And again, the phase between both channels. The button right next to it is the modulation button. If we press it, we come to the modulation tab. As a base channel, channel 1 is the modulation output, but what we want to modulate we can select in the source. Either it's the external jack, which I think is on the back, or we can select some other things depending on which modulation type we want. Let's select frequency modulation. We check the modulation button a few times, and we can select the source, which is channel 2. Channel 2 now modulates channel 1 with a bias of 2 kHz. We can also change this to like 100 kHz. Now channel 1 is modulated with the frequency and waveform of channel 2 with a bias of 100 kHz. If you check frequency or amplitude, we can also change the frequency and amplitude of channel 1. But if we want to turn it on, we have to press channel 1 and we get back to the main screen. If we press it again, it's on. If we select channel 2 and press it again, it's on. If we want to turn off channel 1, we select channel 1 and press it again. And the same with channel 2. The third button is sweep, which explains itself. You can either sweep the frequency, the amplitude, the offset, or the duty cycle. You select the start frequency, end frequency, and how long it takes to reach the end frequency. Then linear or logarithmic. Direction is forwards, backwards, or back to forwards, back, and so on. And it repeats and repeats and repeats. So let's select frequency, and if we hit OK, it outputs a sweep on channel 1. We also can change the waveform that's been swept if you press the wave button. It's always on channel 1. But there is no output currently. We have to turn on channel 1 first, then go to sweep, and then repeat the procedure. Let's turn off channel 1. On the next button we got the counter. It's this one. It's suggested to put in maximum of 5 volts. It goes up to 100 megahertz and it shows the frequency, the cycle, the rise and fall time, duty cycle. You can change the gate, obviously, and the coupling. And if we hit count, it does counting. As easy as that. The maximum input voltage on the counter input is also 20 volts, so you shouldn't exceed that. The next one is VCO, voltage controlled oscillator. On the back we got the VCO in, and depending on the voltage, you can modulate either the frequency, amplitude, offset, or duty cycle from start to end in a linear or logarithmic form, also with a direction of forth back, but not forth to back. So it's just swapping start and end, you know. If you hit OK, it starts. But we have to obviously plug in a signal to the VCO input. The next one is system. As you can see, I got the model FY6800 30 MHz model with a version of firmware v1.6. The language is English. The buzzer I turned off because it's annoying. The uplink is master. That's why in the back are 4 ports. Sync in, sync out. You can stack up to 8 devices and sync them for I think 16 channels. That's incredible. And you make one master and select the other ones as slave. In the config tab, we can change the language from Chinese to English. If you receive the Chinese model, it's the lower button after you press system, and the second after that. We can turn on the buzzer, which is annoying. Yeah. And to get back, we just press system. And under more, we can select if channel 1 and channel 2 is on after you boot the device. If you disable it and you boot the device, it remembers its last configuration. So if you turned it off, if you turned the device off with both channels on, if you turn it back on. And you can reset the settings over there. You can also load and save presets. Already saved the presets in slot 1, and as you can see, it jumped to 1 MHz, amplitude of 10, and all that. To get back, we just hit channel 1 or channel 2 to get to the main screen. Alright, let's see it in action. For this, I'm using my D-scope. I wish it had rubber feet. Let's hook up channel 1. And let's go. Now let's turn on channel 1. And how to adjust the oscilloscope. I also can manually adjust it, but auto is just easier. Currently it's set at 1 megahertz with a V max and a V min voltage of 5.5 volts max and minus 5.43 volts min. It's set to amplitude of 10, but actually it has an amplitude of 11. I noticed that channel 1 is a bit off, and its peak-to-peak voltage is 10.94 on channel 1, even though it's set to 10. Let's change the amplitude down at between 5 and 6 volts. There's a relay clicking, which changes the power rail, I believe. And now it's 5.7 volts peak-to-peak with an RMS of 1.97. The voltage max of 2.85 and a voltage min of 2.85 minus. And that jitter you see on the screen is probably the oscilloscope. I'm not quite sure. Let's increase the frequency to the maximum of 30 megahertz. I go to the most left digit, set it to 3. All digits turn to 0 except the one I just turned to 3. Because that's my maximum. And the oscilloscope is displaying garbage because, well, 100 megasamples at 30 megahertz, that's 4 samples per half wave. Let's turn off channel 2, so we got double the megasamples. And, well, it's a sine wave. Let's change it to a square wave, which obviously doesn't look good on 30 megahertz on this kind of budget setup. And we have to lower the frequency quite a bit. Let's go to 10 megahertz, which should look much better. How to adjust? Yeah, sort of. I usually don't work at that kind of speed. I usually work at sub 1 megahertz. So I'll change it to 1 megahertz, how to adjust the oscilloscope. And, well, we can see square wave. Let's change it to a CMOS. As I told you, at the bottom, let's change the trigger to something better. The bottom is 0, which it actually is minus 240 millivolts, and the Vmax is 2.75 volts. The amplitude on the signal generator also cut in 2. And if we now select the offset and change the offset, you can see we can make it jump by 1 volt down or up. It's obviously DC coupled right now. I can turn on AC coupling over there, but I want the duty cycle. I also can adjust from 99.999 to 0.01, which doesn't display on my screen. The minimum it will display is 0.4%. Let's turn it all the way up to 50% again and check out the other waveforms. That's the adjustable pulse, which works if we change the pulse length. I already changed it, that's why it doesn't show up. We have to change it to a value that's in the range of the frequency. So if we got 1 megahertz and we select the 1 microsecond pulse, we won't see anything. If you go down to 100 nanoseconds, it's obviously 10% duty cycle. And we can go down even further. That's 10 nanoseconds. And I can't go down any further. The next wave is just plain old DC. We can't even change the amplitude, but we can change the volts that's outputting. Let's change it to 10 volts. Adjust this. And maybe change it back to 8. And it's showing 8.7 volts. It's fluctuating between 8.71 and 8.55 with an RMS value of 8.64, which is quite interesting. So let's change the waveform again to triangle. Let's scale up the waveform to 500 millivolts per division. So 5 divisions represent the amplitude of 2.5 volts. Alright, that's triangle, ramp, negative ramp, and the stepped versions. Also the exponent and logarithmic. And the full and half waves. Also the multitone, the random noise, the ECG, the trapezoid, sync pulse, and the impulse, which is so quick my oscilloscope doesn't quite pick it up. The AVGN, AM modulated, the FM, chirp, and the arbitrary waveforms, which are all the same as the default setting, but you can obviously change them. Let's go back to sine wave. If we go over to sweep, we can do a sweep. Let's say from 1 Hz to 1 MHz within 10 seconds. I will choose a linear and a fourth, so it goes from start to end, not from end to start. Let's go. Yeah, it started somewhere in the middle. Didn't start from beginning. Alright, we can also do this with the amplitude. It starts at 1 and ends at 3 volts. And you can see the amplitude is slowly rising. And also at the offset and duty cycle. Let's modulate some signals. For that we have to turn on channel 2. I set it to a square wave. And its frequency I set to 500 kHz. Under the Modulation tab, if we click it, it automatically starts the modulation. Under Para, we can set some parameters, like on FM. We can change how much it's modulating. Under PM, we can change the phase modulation, how much of the phase should be modulated. And burst just bursts the signal, the specified number of times. And if we set channel 2 to, let's say, 100 kHz, you can do up to 10 bursts within a 1 MHz signal. There we can see 1 burst. If you go under Para and change the bursts, 2 bursts, 3, 4, 5, 6, and so on, until we reach 10, which 10 times 100 kHz is 1 MHz. The amplitude modulation, it really depends on the waveform you input. Right at the moment I input a square wave. When I select it and scroll back 2 times, I got a sine wave. And if I click the modulation button now, it modulates with a sine wave. The modulation rate can also be set. Now let's turn off channel 2 and the modulation and just output channel 1 back to auto. And let's connect up our second channel with our second cable. It comes with this jumper cable, a USB cable, a power cable, and 2 of these crocodile clip BNC cables. I wish it came with 2 of these cables, actually. So let's connect it up to channel 2. And hook up those crocodile clips. I know it's not optimal. I know it will distort the waveform at higher frequencies, but I don't have a second BNC cable. Alright. Let's turn on channel 2 on the scope. Set it to 500 millivolts per division, so like the other one. And turn on channel 2. And right now channel 2 is set to 5 volts amplitude. Channel 1 is set to 2.5 volts, so let's change that. Amplitude. Go up to 3, 4, 5. Let's go back to channel 2. It's running at 100 kilohertz. Our channel 1 is running at 1 megahertz, so we should see 10 waveforms within one waveform of the other channel. Let's zoom out a bit. There we go. I just stop the scope and we can see the green line, which is barely visible on the camera. We can also set the trigger on the green line. Let's do that. Just channel 1. Start. And now the waveform is rock solid. Or we can change channel 2's frequency or channel 1's frequency if you select channel 1 and then frequency. It also remembers the cursor. If you go to amplitude on channel 1, select channel 2, I'm back at frequency. Let's change this to duty cycle and go back to channel 1, and we're back at amplitude. Let's change the frequency to 500 kilohertz. And at channel 2, we change the frequency to 250 kilohertz. And we change the phase to, let's say, 90 degrees. Sort of apart, so they look a bit apart from each other. Let's change the frequency to the same, 500. And as we can see, the waveforms are apart from each other at 90 degrees. 180 will be, well, inverse. Maybe you can see it on the camera, but the green lines are a bit smaller than the yellow lines. The yellow lines is channel 1 and the green is channel 2. At channel 1 we have, as I said before, a slight offset to everything. Right now the VPP, peak-to-peak voltage of channel 2 is 5.31 volts, which is set on the signal generator to 5 volts. And the voltage on the channel 1 is 5.7 volts, which is also set to 5, so it is a slight imbalance. And I didn't found the calibration menu on this device yet, so maybe there is one, maybe there isn't. I don't know. Maybe there's a potentiometer inside to control the thing. Alright, let's check out the counter. For this, I turn off channel 2 and disconnect my scope. Let's hook up the counter port to channel 1. Obviously you don't do this in your normal situation. You got this running to your breadboard and this coming from your breadboard. But for demonstration purposes, let's do this. At channel 1 I set the waveform to square wave, running at 500 kilohertz. Let's change that to 100. At amplitude 5, duty cycle 50%. Let's go to counter, and there we go, 100 kilohertz at the gate of 1 second. If we change it to 10 seconds, it does the averaging within 10 seconds of the signal. You can see the rise and the fall time, as well as the cycle and the duty cycle, which may be hard to see on the camera because I can see on the device itself. I'm looking from an angle from above and it's quite dark blue. Let's change channel 1 to, let's say, 10 Hertz. Go to the counter. Yeah, it shows 10 Hertz. There we go. And now if we select count, it counts up 10 by each second. Easy. And we can stop it, start, or 0 it. If we change back to frequency and back to count, it also resets. We can change the gate time up to 100 seconds. And the coupling, obviously. And if we change the duty cycle to, let's say, 75, it also shows up as 75. Alright, that's it for the technical view of the FeelTech FY6800. Now I continue with the teardown of it, and if you're interested, keep watching. And here's the teardown of the FY6800 function generator. I already taken the lid off before to take a look inside, and it's just held down by these screws. On the inside we can see the power supply, and this model features, other than its predecessor, a C13 IEC jack, which allows for grounding. The problem on the previous model was those BNC connectors had a potential higher than the ground because they weren't grounded. And this one, since it got ground, let's measure if the ground is actually connected to the BNCs, because if it is, then there should be no potential between these. Some users of the previous model mentioned a potential about 60 volts leakage through this device from the mains to the BNC connectors, and if they are grounded, there should be no potential, except if the cable is broke or if your wall socket isn't grounded. Let's turn on the meter. Yes. And check the BNCs. Yes, they're all grounded. That's fine. That's good. So let's take a closer look. It's powered by a switch mode power supply, which outputs 5 volts, plus 12 volts, and minus 12 volts to get some headroom for adjustment on the amplifier stage. On the inside we can see a big chip and a heatsink, and let's zoom in. On the left side there's a Cyclone 4 FPGA from Altera. On the bottom and top there are some unbranded chips. I believe there are digital to analog converters. But these two are MCP4802, which are also digital to analog converters. One output goes to the heatsink, and the other output goes into one of each of these chips. Under the heatsink, I don't want to take it off. Maybe I break something in this process, even though it's screwed in the middle. There are just op-amps from Japan Radio Corp GRC, maybe 455D, not quite sure. Op-amps under there, and there are some NEC relays around. For powering the FPGA, we got a 3.3 volt regulator, a 1.2 volt and a 2.5 volt regulator. Over there is a CH340G USB to serial converter, which has a jumper cable from here to the front panel. On the left side we can see an EEPROM and a 50 MHz clock. Down there is another op-amp, and this one is a CMOS transceiver for driving those TTL outputs and all that stuff. On the front panel there is just an STM32F103, the same one as in these blue pill boards, which are quite powerful, but this one is another crystal, which is 8 MHz. There's the ribbon of the LCD, which is a color LCD, and that's the programming header for the STM32. Unfortunately, there are no firmware files available. Over here we can see the ribbon cable going to the FPGA and the other cable coming from the CH340G serial to USB converter. And it's also labeled 5 volt ground TXD and RXD. And the beeper, which is quite annoying, has a seal on it, remove seal after washing. And if we look over to the rotary encoder, we can see it hasn't been washed. So that's the guts of the FY6800 function generator from FeelTech. It's quite a simple design, very few parts, and that's why it only cost 80 or 100 bucks. I think I paid 99 euros for it, but the price will drop someday. One quick note to mention, the manufacturer also provides software for your PC, which I currently have running on my Windows machine, which also lets you set custom waveforms and let you control the device itself. As we saw in the teardown, there is a CH340G USB to serial converter. The manufacturer also provides somewhere, I haven't quite looked it up yet, but I know there is some, a lookup table for all the serial commands, so you can control it with your Arduino if you want. There is a serial port on the back, and well, it lets you control everything basically. Well, that's the review of the FeelTech FY6800. I'm Gamer Petty, and thank you for watching.